welcome to the session. I think I had to have something about containers in the title, and then the room would be getting more attention. But anyway, cloud is not as attractive as it used to be. So thank you for coming in. So I'll talk a little bit about our company before I jump into the actual cloud talk. So I'm working for a company called INFINIDAT. How many people here have heard about INFINIDAT before? Okay, great. So we are out there for the last probably about 6 years. Right, the company founder has much longer track record with the industry. Right, Moshe and I is our founder and CEO. He's the guy who was behind Symmetrics and then XIV and few other things, and this is something that we call like Moshe 3.0, right? So the INFINIDAT company, where we are trying to solve problems of companies that need to store large amounts of data. All right, so the company exists since 2011. We have about 450 people today, and we are shipping quite a lot of storage. So we have about 1.7 exabytes of storage deployed today globally. So this is the product that we have. That's our main product today. We call it InfiniBox. This is a hybrid storage array that we sell for customers who deploy it as an on-prem storage solution. This is a hybrid storage array, meaning that most of the capacity goes into the spinning drives within this system. And then we have massive RAM for the write caches and SSD for the read cache. All right, and the architecture allows us to have very good ratio of compute nodes, controllers, basically, to the storage capacity within the rack. So because of the architecture, we can provide performance which is comparable to all-flash array. In some workloads, we outperform all-flash arrays, but we are talking about hybrid storage, so the price performance is very attractive here. And this is a unified storage, so we offer Fiber Channel iSCSI, NFS out of the same storage system. So this is pretty much the product that we have. It goes really well on the market. We have many very large customers. The scale of this product, we're talking about hundreds of terabytes to petabytes of capacity per deployment. And we are selling to like Fortune 500 customers globally. Now, one thing that we hear a lot, and that brings me to the topic of my conversation now, is all those customers that are deploying our storage, they're deploying this on premises. And they're very happy about it, and those are usually kind of more conservative companies, banks and insurance companies, and actually many cloud providers who deploy us as well. So they are starting to think about the way to offer hybrid cloud solutions to their customers, whether it's internally or external customers. And then they ask us, okay, what can you do for us to provide this kind of hybrid cloud story? How can we do to get all the benefits that you offer in your storage, but how can we get something like that in the cloud? So this is something that we are looking into today, and I'll talk about this. But before that, I want to talk a little bit about the challenges with public cloud storage in general, right? And this is what I put here with the Hotel California quote. Basically, in many cases, when you are going into the public cloud, if you go to Amazon or Azure or anybody else, it's very easy, well, relatively easy to get into the cloud. But then if you want to get out of the cloud and take your data out of the cloud, that becomes a bigger challenge. There are many reasons for that, but one of them, as we see, is really the cost of taking your data out of the cloud. That becomes really big once you have large footprint. So there are other challenges, right? First of all, if you have your legacy applications that are built for block or file storage, going into the public cloud, which in many cases, many people believe that cloud storage equals object, like S3 in Amazon, this is challenging, right? You have to tune your application. You have to make sure that your application can consume cloud storage, like object storage, which is the most commonly known there. But my point here is that actually when we talk about the cloud storage, it's way more than object. How do you get your data to the cloud? That's another challenge. So like Amazon today offers this service of the snowmobile where you can get this huge truck that gets to your site, you copy the data, and then it physically drives it back to Amazon and copies the data. But this is something that is not very simple to everybody. So getting data to the cloud is a challenge. Talking about the cloud cost, right? So again, there is a common assumption that cloud storage is cheap, and this is not always true. So this is a calculation for what would it cost you to have about 16 terabytes of block storage, right? I'm not talking about object today, I'm talking about the block and file, so more kind of primary storage type of things. So if I want to create a 16 terabyte of EBS storage in Amazon, that would be about $20 to $100 for me per month, right? Additional thing, assuming I'm talking about the primary storage, right? If I want to use provision storage, I have to pay more for the actual IOPS consumed, IOPS provisioned. Now, let's assume I want to create a snapshot of that data. So snapshot in Amazon means I take my data from EBS and it gets copied into S3. So I pay extra money for the S3 capacity. And then if I at some point want to take the 16 terabyte of data back to my on-prem data center for whatever reason, right, I have to pay for egress cost. So that's pretty high cost for, depending on the use case, right? There are concerns about data sovereignty, especially in Europe, that we see. And something that is really big is availability and reliability of the data. So there was a talk earlier today here in this room from Backblaze guys who share these great numbers about the availability of physical drives, consumer space drives. Right? And they talk, depending on the vendor and the model of the drive, for physical consumer level drives, they get an average failure rate of about from sub 1% to about 2% for kind of worse drives. Now, if you look into the numbers that Amazon published for EBS for block storage, which is actually kind of the rate-protected capacity, right? This is not a physical drive. This is actually kind of a rate-protected drive. They are talking about 0.1 to 0.5 failure rate, and this is for 20 gigabyte drives. So the bigger the drive, the more chances are that you'll get the failure. Now, this is not just a theoretical number. We do not consume much of EBS storage, but this is the mail that actually one of our engineers got from Amazon. This is how it looks like. Your Amazon EBS volume experienced the failure due to multiple component failures, and we were unable to recover it. Sorry. Okay, so the data has gone, and the assumption that they have is that, okay, you want to have data persistent, you have to have snapshots. The snapshots, again, as I said, it has to be copied from EBS to S3. So we'll see how long this takes. And those are things that kind of are painful to many people. So this is about the data protection, as I said. If I want to take a protection for the EBS volume, right, I have to create a snapshot. This is the command line that I can use. If I run the command like create snapshot for EBS volume, I get the response back instantly. But this is an asynchronous process. So I have just 4 gigabytes data used on my 50 gigabyte EBS volume here. The time it takes for me to actually complete the snapshot creation for the first snapshot, it's about 4 minutes. Okay, so for this time, my data stays kind of unprotected. And if I'm looking about to other type of storage, for example, Amazon has today what they call the elastic file services, the EFS, the NFS service. It has no snapshots at all. So if I want to protect my data on EFS, I have to do kind of rsync or whatever way to replicate data to somewhere else. So we looked into all those things, and we also had some customers who, as I said, asked us for enterprise-grade storage offering, which would be accessible within the cloud. And this is what we're talking about. So it's not a product that we announced yet. We're running some beta pilots today, and if anybody's interested, talk to me after that. But what we are starting to offer today is basically a service where we have our storage with all the features that we offer for the enterprise and reliability and performance and everything else. And instead of selling this as the CapEx to the customers who deploy it on-prem, we manage the storage and we sell capacity on demand, kind of storage as a service. So there are two use cases as we see for that. One is you can have, if you have a storage on-prem today and you want to migrate it into for kind of DR purposes off-prem or make it close to the cloud, you can use our replication and replicate the data to this multi-cloud storage cloud. The other use case, which is very interesting for many of our customers, is an ability to access those volumes and file systems that we have here from the public clouds. So we locate those systems in colo facilities that have data centers adjacent to the public cloud data centers. So we can ensure low latency between those environments and our storage. And then we provide iSCSI and NFS access to virtual machines running in AWS, Azure, and soon Google Cloud to this data. So as a result, we can offer an alternative to EBS or EFS, for example, with Amazon, or similar things with Azure using the enterprise-grade storage. So how can it be consumed? One thing that people can use it, right, is, okay, in Amazon, I may have multiple availability zones within my virtual private cloud. What we create is basically a direct connect from our environment in Colo into the AWS virtual private cloud and provide access to volumes and file systems that you may create within multi-cloud environment. It can be accessed from one availability zone. It can be accessed from multiple availability zones, depending on the setup that you have. You can have multiple regions. This is something that we do not offer today for the pilot, but we plan to provide this later, is an ability to share data between multiple regions. So you have our region, let's say, in US West, in California, and you may have a region in US East, in Ashburn, and use replication outside of the cloud to ensure data access from both locations. So this way you get efficient data replication and you do not pay the costs of cloud when you have to transfer data between regions. And something that is very interesting for many customers is really what we call multi-cloud access. Meaning you can have our storage and you can consume it simultaneously from both AWS and Azure. Right, so we can have, for example, a file system that could be mounted at the same time to an instance running in AWS and an instance running in Azure can read and write data. Okay, but by the way, if there are any questions, you can stop me at any time, ask.
Would that be when you share it like that, is it on the same physical hardware?
Yes. Okay. And it sits outside. So one thing that we see, and I'll talk about some use cases and why people like this idea, is an ability to leverage cost of compute between different clouds, right? So you can say, okay, I'm getting cheaper compute now in Amazon, I'll run there. I'll get cheaper compute tomorrow in Azure, I'll run there. Or whatever other reasons they may have. Yeah.
Do you expose a common interface towards these multiple clouds? So S3 access to both?
No, we're talking about S3. We're talking about NFS and iSCSI. So I said at the very beginning that cloud storage is way more than object, right? So we do not offer object today. We provide NFS and iSCSI, and you can consume it from any cloud. So let's see a demo here. What I'm going to show here is basically we have our storage, right? I create a file system on INFINIDAT multi-cloud storage environment. I use Direct Connect to access this file system from AWS instance. I use ExpressRoute to access this data from Azure. And Google just recently announced their own L2 connectivity to public cloud. When I made this demo, there was no this L2 available, so this is a VPN over L3 connection to GCP. So what you can see here, I can go ahead, assuming I'm a customer who runs within INFINIDAT multi-cloud storage environment, I can go ahead and create a file system with whatever name and size within this environment. I can export that file system and define the export permissions, assuming those are my subnets that I use within AWS and Azure. Right? And then I can go ahead on any instance in those public clouds that I've created connectivity before. What I'm not showing here is the connectivity creation between our storage environment and customers' VPC in AWS or customers' VNet in Azure. So this is something that is done before. Then I can log into my instance and create the mount, and then I can see this mount available. And so I can do this. Let's say this is my AWS instance. Right? I can mount my file system as mnt/nfs, and I'm writing some data into a file on this AWS instance. I log into another instance that runs in Azure and write some data to the same file on the same file system. Then I can read this file on an instance that runs in Google, and I can see the data that gets in. Okay? So this is the way to provide concurrent access to NFS. This is another example of usage. I can do the same thing as I do with NFS. I can do iSCSI. Now, I do not expect someone could potentially install some kind of a clustered file system and ensure lack of data corruption if you do block storage shared between multiple instances. But I'm using a simpler case here. So let's say I have an AWS environment. I'm running MySQL server within AWS, and I store my database on iSCSI volume served from INFINIDAT multi-cloud storage. So what I'm going to show is that I can instantly take a snapshot of that database and expose it to Azure and provision a MySQL server running in Azure using the same data. And because we provide both read-only and read-write snapshot, this could be actually a real working MySQL instance that can update the tables. So again, this time I'm using this management interface that we have for the multi-cloud storage environment. To create my volume, I can define my host, like my SQL machine, with this IP address from AWS environment. I can do mapping for this host to the volume. And then I can run on that host, I mount my file system, create a file system, and start my SQL server. So now I can go to MySQL in AWS, create some table, load a lot of data, whatever I'm getting here to about 99 million records in the table. And you can see that this table is about 6 GB of size. So, by the way, the example that I showed at the very beginning of data protection in AWS, where it takes me about 4 minutes to create a snapshot, mentioned 6 GB used out of 50 GB file system. That's exactly this case. So if I do the same thing on EBS, and now I want just to create a snapshot of this volume to have it protected on AWS, that will take me about 4 minutes. Now I want to take a snapshot of this volume using our multi-cloud storage, which happens instantly and does not consume extra capacity. As long as there are no changes, the snapshots are free. So I create a snapshot. I can now map this snapshot to my Azure instance. And I can basically create this mapping. Now when I log into my Azure instance, I mount the file system, I start my SQL server, and then I can see that I have the same 99 million or 99 million and 5 records. So I have instantly created copy of my SQL database taken between AWS and Azure. I can use the same thing, for example, to share my data from on-prem environment in cloud as well. So let's say I have my database on-prem, I can use replication component to bring this data from on-prem environment into this INFINIDAT multi-cloud storage capability and then expose this to AWS or Azure or both instantly and have this data there. So I can show also that I can actually modify this database because this is a writable snapshot and add more records and whatever, go to 299,000 records.
Are your snapshots application aware?
So the snapshots that we create, they can be created with plugins for application that will make them application aware. So a little bit more about comparing snapshots, for example, with EBS to what we offer here. Right, so as I said, EBS snapshot, this is a quotation that I took from AWS documentation. Depending on the size of your EBS volume, it may take you several hours to create the snapshot. And you can see that this may also take a lot of time, even if you do subsequent snapshots, if there are many changes. Taking a snapshot takes time because, again, every snapshot in AWS is a copy of data from EBS to S3.
Isn't that the difference between a fully provisioned snap and a pointer snap over here? Or is that what makes that difference? You have to do a pointer.
No, I'm talking about why our snapshots are different. So in our case, we basically freeze the environment. That's the way we do snapshots, and we know that okay, those blocks were written by now. That's what our snapshot is. And then we keep writing to other areas on the disk. So that's the way our snapshots work. And there's a difference in the architecture. So in AWS space, it's basically a copy of the data. Now, our snapshots are also instantly consumable. So the snapshot can be mounted as read-only or as read-write on other hosts and used for whatever reasons. You can do it for backup. You can do it for dev test environment, and so on. With S3, you have to restore snapshot to be able to consume the data. You can't use the snapshot itself. Performance impact. Again, if you take AWS snapshots, it may have impact on your performance. In fact, they actually do not allow you to take more than, I think, 5 snapshots of the same volume. So you take a snapshot that may take time. If you have many changes on the files on the block device, and you want to take another snapshot, let's say in a few seconds or minutes, if the previous snapshot creation is still running, the new one will be kind of added to the queue, but you can't have more than 5 of those. There is no impact on performance with our snapshots. Again, storage consumption, when you take a snapshot of this 50 gigabyte volume, you have to pay now for 50 gigabyte of capacity in S3. And so on. And we do writable snapshots as well. So, big question that many people ask is, what about performance? The native storage runs in public cloud. If we talk about EBS or EFS or block storage in Azure or file storage in Azure, and you guys are running outside. You're running adjacent to the cloud, but not in the cloud. So what does it mean from the performance point of view? So I was doing a test here. Let's say I'm running an instance, which is a very large instance in AWS, which has full bandwidth for 10 gig connection. That's what Amazon claims. Accessing the Elastic File System service in AWS. I'm running similar instance in Azure, which is called DS5 v2, and access Azure File System, which is hosted file system provided by Azure, and also accessing the NFS file system from our storage over 10 gigabit link. So we can create different connections between a different bandwidth between the instances running in the public cloud into our environment. So, by the way, in fact, this 10 gigabit express route, that's a 10 gigabit provision bandwidth, but Azure does not support 10 gigabit. Azure allows us to get 9 gigabit link because of the limitations of the VNet virtual gateway that is consumed there. So this is a kind of 9 gigabit. We can have multiple lines provisioned as well. But for the sake of this test, it's single connection. And those instances are running Ubuntu, running VDBench as a test. So those are some tests that we're running there, right? And they can show the latency, and the lower the better, and the operations per second that I'm getting running those tests. And this is actually log 10 scale. So the numbers here, the yellow one is AWS. I don't know if you can see it at the back. Hope you can. the blue one is Azure, and the green one is what we are sharing. Now, first of all, there is certainly a latency that is added because of the distance between our storage and the actual public cloud environment. So this latency is, depending on where it's happening, it's about 2 milliseconds. And if you look into a single operation latency, obviously there's always this extra 2 milliseconds or 2.2 milliseconds that we have to pay because of the distance. However, when we are looking into a large amount of IOPS running, right, this 2.2 millisecond latency overhead becomes really irrelevant. And those are the actual numbers that we see. So there are 4 tests that were kind of represented here. We have random read 4 kilobyte block, random read 64 kilobyte block, sequential write 4 kilobyte block, and sequential write 64 kilobyte block. So what is interesting here is that with the file system performance access, we get consistently lower latency, even though we are running outside of the public cloud, comparing to both EFS and Azure file systems. And we are getting to higher operations per second. Again, depending on the workload, but with those tests, we see it clearly. Right, so this is an example, if I'm kind of comparing the interfaces that someone can use to provision a block storage in Amazon, as opposed to provisioning block storage with INFINIDAT multi-cloud, right? So the commands are very similar. This is the AWS command. I have to create a volume, 10 gigabyte, and I define what availability zone it should be accessible from. This is one other thing that is different, right? So the EBS volume can be accessed within the availability zone. With our volume, you can access it from any availability zone because it's external to them. You have to attach a volume to host. We do host update on our side. Then you have to create a file system and consume this volume. That's the same. So the ease of use is very similar. Some more details if we compare those offerings between EFS, Azure file, and INFINIDAT file. Right. First of all, number of file systems. With EFS, today you can go and create up to 10 file systems per region. Now, the reason for that is that from Amazon point of view, they do not really limit your file system by size. So if you mount an EFS file system and you do GF, you will see 8 exabytes, I believe. And that's something that might be good and might be bad. So the bad thing for that would be that from the Amazon point of view, this is great. You store as much data as you want and you just pay them more. Right, so there is no quota controls. There is no way to limit the user from consuming capacity. If you have a runaway process that generates tons of data, you will get the bill at the end of the month. So you can't have multiple file systems, and you can't limit the size of the file system. The other thing is the max NFS ops per second that you may get to the file system. Those are the limit with EFS, Azure File Storage, which is actually an SMB implementation with access to object storage behind it is much lower than that. We are talking again about the limit mostly by the network bandwidth that you provision between INFINIDAT multi-cloud storage and your Azure or AWS environment. So with 10 gigabit link, getting to about 87,000 NFS ops per second. And again, if we get multiple links, we can have higher than that. Again, depending on the workload, obviously. Bandwidth per file system, or throughput per file system, I have to say. So EFS can scale to very high numbers. Can go to, well, relatively high numbers. Can go to several gigabytes a second. But the scale comes with capacity. So the more data you store in EFS, the more throughput you can get. Now, if you do not consume really petabytes of capacity within EFS, then this is how it scales. You get initial 50 megabyte a second throughput. And for every terabyte that you use, you get an extra 100 megabyte a second. Okay, so if you have a relatively small amount of data in EFS, your throughput will be limited. With Azure files, With Azure file storage, you are limited to 60 megabytes a second. And in our case, again, it depends on the network bandwidth that you provision with 10 gig to Azure, which is essentially 9 gig, as I mentioned, because of the Azure limitations. That's over 770 megabytes a second. Other things like file scalability, Amazon supports 52 terabytes, which is probably good enough for most of the environments. Azure supports up to 1 terabyte file. In our case, we can go actually to have a file as large as the entire system or whatever. So we really do not limit the size of the file. Capacity control, I think this is something that is important. As I said, on EFS, you can't have a quota. You created a file system, and then this file system is essentially endless. You can store and store and store data, which means you pay more and more money. So this may work well for the provider. It might not be so good for the CIO. And so having an ability to limit the file system by some size and take control over the end user, how much data he really stores, is very important for usually IT organizations. Right? So there is no limit on AWS side. There is a limit of 5 terabyte as a max limit size for the file system on Azure side. And you can go up to half petabyte per account. In our case, you can define max file system size. You can have, if you want to, but if you don't, you can have file systems over petabyte. You can't have access to the same EFS file system from multiple virtual private clouds. Your EFS exists within VPC. In our case, you can have multiple VPCs and they all can have access to the same file system. But something that is actually more interesting, and we see demand from customers for that, is an ability to do this in the multi-cloud environment. So there is no way you can share EFS between AWS and Azure, or there is no way you could share Azure file storage between AWS and Azure, but if you need that, you can go with our solution. We talked about snapshots. There is no snapshot for EFS. There is no snapshot for Azure block, for Azure file, but we do offer the same scalable snapshots for file systems as we do for the block devices. So again, writable if needed. So use cases. So cloud on-ramp, that's one thing, right? We have customers who have capacity on-prem and they want to be able to provide access to some of this data from the cloud, so they can replicate the data from on-prem environment into the public, into this multi-cloud storage, and then expose the snapshot of it to the public cloud. Hybrid clouds, again, not moving the data, but keeping the data between on-prem and the cloud environment. Doing things like dev test environments, so we can provision multiple snapshots, multiple writable snapshots of our data in the cloud for free, pretty much, right? We do not charge for amount of snapshots or amount of volumes. We charge for used capacity. So if there are snapshots that do not have many changes, then they're basically free. Burst capacity. Again, you have your environment on-prem. You want to leverage capacity in the cloud. Remote data protection and the multi-cloud storage. So one example with this, for example, we talked with one of the large genetic research institutions. We actually like working with these guys because they consume a lot of data, and that helps. So they had a project where they planned to have about 2 petabytes of capacity for genomic data in each one of the 3 clouds. So AWS, Azure, and GCP, and consume compute capacity from those clouds for different research purposes. Now, the original plan was to really have 3 copies of this data, so 2 petabytes in AWS, 2 petabytes in Azure, 2 petabytes in GCP. And we said, okay, but what if you would have single kind of master copy of the data accessible from all 3 at the same time? And this is something that helped us to get to an interesting discussion, and we'll see how it goes. To summarize, right, we see that, and definitely when we talk more about kind of legacy or traditional enterprise environments, people are starting to think much more about the public cloud or hybrid cloud. There is a lot of kind of the CIO mandates going into public clouds today, everywhere. And when these guys want to go into the cloud, that does mean they can modify their applications and start consuming the object storage. So they are talking about the block and file, because this is the way the applications are written. So offering enterprise-grade block and file solutions in the cloud, in public cloud, becomes a real need. And from our point of view, we can provide this kind of flexibility of moving between cloud A to cloud B. You do not have to pay that much money for taking data from cloud A to cloud B. It can be accessed between clouds, it can be accessed on-prem, and it can be used with multi-protocol as well. So you can do iSCSI, you can do block, you can do file. Looking into the economics, we do not talk about the pricing today for this, right? So as I said, we are in kind of the beta pilot stage today. And so if somebody wants to join this beta pilot, talk to me. It's free for now. You get 25 terabytes of capacity and do with this whatever you want, as long as we understand what you do. But once we start charging for that, that will be competitive comparing to the costs of block storage or file storage available in public cloud. And then we provide all these features that you would expect from the enterprise storage, whether it's snapshots, whether it's NFS, and so on. And we're talking about performance, which many people do not expect from the cloud adjacent storage, but we actually outperform the native offerings there. So few other things you may see in a demo with this MySQL provisioning between AWS and Azure. It's actually on YouTube. That's the URL. If you are interested in kind of more discussion and would like to hear more about this offering and maybe join the pilot program, please contact us at this email. Open to questions.
I mean, I understand how you make it available between your clouds. Makes sense. But how do you address regional availability? If I want East, West, US, or European.
So this is something that we do not do it today during the beta stage. We do plan to do it once we go to the GA, right? So what we have is very efficient way to do data replication between our storage systems. And this is really the plan. So we can offer replication between our systems at the back end, and then you can access the data from the clouds in different geos. So assuming that we define here a VPN tunnel over network and provide the bandwidth, right? That's something that will be an extra cost, obviously, for the cross-site access and cross-geo replication, but that's something that we still plan to provide.
And that's still in development.
So this part, yes, this part is. So right now, if you want to join the pilot, as I said, we have capacity that we offer here in Silicon Valley, and you can access it, consume it from US West regions, from AWS or Azure. Of the cloud, correct. So what we do is, as I said, we create this connection, right? If that's express route for Azure or direct connect for AWS, which has reduced cost. So there is still an egress cost of data going from public cloud to us. There is still an egress cost. It's about 1/3 of the egress cost if you go and take data from the cloud through the public internet. So it's much lower cost there. And we also see that most of the use cases that we are dealing with, they are doing usually like 80% read, 20% write. So that means that whatever is read, like 80% of data, is actually an ingress, so it's free. The 20% write, or lower than 20%, that's something that there is a cost associated with that, but it's usually not that high as some people are concerned with. Other questions? Yeah. No.
Much customers can share one INFINIDAT port.
So the question was if we are going to support multiple tenants, multiple customers on the same InfiniBox storage. So the answer is yes. The plan is to provide a shared environment. Now, from the customer point of view, he won't see that the physical infrastructure behind it is shared. Again, similar to what you would expect in any public cloud, right? In most of the cases, you will see that when you run your workload in AWS, right, your instance runs on the same compute server as somebody else's instance. Same thing here. So yes, the capacity will be shared. Now, one thing that we do is we are abstracting this view of our physical storage from the end user. So when you create an account with INFINIDAT multi-cloud storage, you do not really see the Infini boxes. You do not see the actual systems that we have. All you see is your volumes and file systems and snapshots and what hosts they're mapped to, but you do not see the underlying box and you don't see other tenants, obviously.
Can we use any private IP address, like 192.1?
Yes, yes. So when we land your, we create the connection to your VPC or your VNet, right? We have to know what subnet do you use, what CIDR do you use within VPC, for example, obviously, right? We also ask you to choose between 3 options that we provide you for the IPs to access our NFS or our iSCSI. Right, so that it does not overlap with anything that you might be using in your environment. But yes, we can do multiple or private networks, whatever you use. Yes. No, it's our own snapshots. Yes, we have our own file system.
How do you prevent data leakage from one customer to the other?
So the data itself, we create the network connectivity using VLANs. So there is a VLAN segmentation between different customers, between for example, your VPC all the way to our storage. Right. So this is how we do the data over wire segmentation. On the storage behind it, this is something that, this is how we store the data, right? So the same thing as on-prem. We do not get to the situation when data on 2 volumes gets overlapped. But on the network side, it's VLAN segmentation, and we also, for some people who are, very sensitive about the data, we don't see that much. Technically we can do it. Nobody really asked for that today. Is we can do also a VPN tunnel, like IPsec tunnel, on top of direct connect. So this is usually not required because, again, that's kind of a dedicated connection, but we can do encryption on top of direct connect as well, or express route. Yeah.
So in a multi-tenant configuration, I would definitely have the use case where, the company I work for, we acquire several companies. So if we're going to bring those companies in, is there a role-based access that can be provided for their end users depending on the level of administration we want to provide for them? Because some of them may not want us to have any administration into their storage. Some of these companies may want us to perform all of it, so I'm just trying to understand how that multi-tenant component would work in that case.
So I think we should talk more offline about this because, again, the case that we see today for this is that we offer this capacity to the end user that may or may not have this kind of real multi-tenant sub-customers. So what we are doing today is when we create an account for the customer, we create this kind of a master tenant account, and then within this master tenant account, you may have multiple user accounts. But within the tenant, there is no separation of. So everyone can handle his own volumes, but he can see others' volumes within this tenant. So one thing could be is for each one of your customers would create a separate, what we call the billing account or tenant account, and then they'll be completely separated. But we can talk about this more offline. Yeah, there was another question? So again, we do not do object. It's block and file. We do iSCSI and NFS. And this is exactly what I mentioned initially, is that we see that the demand for cloud storage is way more than for object. Because again, people are starting to migrate their legacy environments that are not object tuned. So our competition here is really EBS, EFS, and similar things from Azure and GCP, not S3. At least not today. Other questions? Okay, thank you very much.